Hello, thanks for tuning in to this session. I'm Michael Thomsen, and I'm a product manager working on Dart and Flutter. With me today is Andrew Brodgon from our developer relations team.
Hey, everybody.
Today, we'll give you an update on what's new in Dart and Flutter. Our core mission remains unchanged. With Flutter, we seek to enhance app development via a dedication to 5 core characteristics. Flutter is beautiful, giving you complete control over every pixel on the screen. It's fast, powered by hardware-accelerated graphics. It's productive. Your workflows are supported by hot reload and DevTools. Flutter is portable. A single shared code base enables any platform your customers care about. And finally, it's open. We're free and open source. Being able to see all of our code enables you to learn from it and customize it. Much of this is powered by the Dart language and its flexible compilers and tools. Having a single team work on the language and framework together enables us to make deep investments across the stack. We'll show several examples of this today.
We'll also talk about how companies around the world use Dart and Flutter to solve problems and build their futures. In fact, let's take a look at one of their apps right now and see how the developers behind it are putting Dart and Flutter to work.
When I was younger, investing was complicated for me. The thing I like the most about my job is it allows me to use my software development skills to reduce that complexity and make it more accessible for others and easier for them to invest and save their money with confidence. I'm Sam Moore, VP of Architecture at Betterment. Betterment is an online investment company registered with the SEC and FINRA. We're based in New York City, and we currently manage over $34 billion in assets across 770,000 customers, making us the largest independent robo-advisor in the market.
In 2019, this is when we started to see a huge shift in our customers' behavior, and we knew that we needed to meet them where they were, which was on their mobile phones. So at this point, we decided to shift to a mobile-first strategy, which came with all sorts of challenges.
Before Flutter, we had to build most of our features twice, from design phase to product requirements phase to implementing them as engineers. We decided that we'd look at cross-platform mobile development strategies, and Flutter was the option that was the most exciting to us. So we put together a rubric of sorts with things like, does the app feel native when we build it with Flutter? Can we support accessibility features that are important to our customer base and that we need as a regulated company?
And so we piloted Flutter against this rubric with just a small team of devs, building it alongside of what we already had to see if it really held up. And it did.
We needed to get all of our engineers excited about this new language, to get business stakeholders excited about maybe slowing things down a little bit in order to gain a lot of time in the future.
We put together a plan where we would carve out 2 weeks for engineers to learn the foundations of Dart and Flutter, build new components for our design system, and then carry that into new feature development with Flutter.
It was a really great experience for our team to learn something new and really become more well-rounded engineers.
Being able to build their app and change things and see those changes in real time was life-changing for many of them. After migrating to Flutter, we were able to take feature development and reduce it by half. We could build the majority of our functionality in a platform-agnostic way. That was really pleasing to our design team, our product team, and ultimately our engineering team, as they could deliver more things in the same amount of time.
One of the things that Flutter has done, it's really enabled us to build a really cohesive and beautiful customer experience at a faster clip.
So before we were always trying to catch up to what the web was doing, and now we were able to ship features in parity with the web and even outpace them at times, which was really exciting to see and a real just accomplishment from our team. And that was all because of Flutter.
Hopefully this has you excited about Dart and Flutter's unique qualities. Let's turn our attention to the new features we're launching today and a preview of what's coming next. We'll structure this using the 4 categories we introduced earlier this year at Flutter Forward. Continued focus on developer experience, breakthrough graphics performance, seamless integration for web, desktop, and mobile, and early to new and emerging architectures. We'll start with developer experience. And first, the Flutter framework. Then next, we'll talk about Dart and developer tools. Today we're announcing Flutter 3.10. This is a great release with lots of additions, with the goal of making you even more productive. First up, we greatly improved our support for Material 3, our comprehensive and adaptable widget toolkit. We now support Material 3 algorithmic color schemes. These allow you to effortlessly generate a complete color scheme from a single seed color. And the generated set is guaranteed to be accessible and look great. We've added the Material 3 drop-down menu and the very smooth-looking Material 3 navigation drawer. The tab bar now supports secondary tabs, and the tab bar and snap bar widgets have been restyled to match Material 3. Finally, there's a brand new search bar widget, which makes it really easy to create rich, interactive search experiences. We've also made improvements to the framework to make it easier to build great iOS and macOS apps. Spell checking is now supported in the editable text widget, so this feature is now available across all of our platforms. We've added a new checkbox widget, and we've updated context menus to have better visual fidelity. To make it much easier to use physical devices for testing, you can now connect to these devices wirelessly, which is much more convenient. So, in summary, lots of new widgets and tooling enhancements to make you even more productive when developing Flutter apps. And speaking of developing, let's turn to the Dart programming language. I am thrilled to announce that today we're releasing Dart 3 Stable, our largest Dart release to date. Dart 3 contains 3 major improvements. It is a culmination of our multi-year journey towards null safety. With Dart 3, all code now has sound null safety, reducing runtime errors and improving performance. The Dart ecosystem has done a great job preparing for this moment. 99% of the top 1,000 packages on pop.dev already support Dart 3. Next, we've added 2 new language features. There is support for structured data with records, destructuring, and pattern matching. These all facilitate modern programming with abstract data types. And we've added class modifiers, a power user feature that enables package owners to better express the capabilities of their APIs. Patterns is the largest new feature in Dart 3. We think that all Dart developers will instantly benefit from this feature. For starters, they allow you to build up structural data. In this simple case, we see a function that can now return a pair of elements. And it's much easier to work with such structured data. Down in the main function, we see how we can easily destructure that data back into its individual elements. But there's more. With patterns, it's also a lot easier to write code that is conditional on the structure of the data. Here's an example of such structured data, a class hierarchy with a shape and 2 subtypes, square and circle. We'll use the new switch expression to implement calculate area. First, we'll add a switch on the shape, and then we'll switch on the type. First square, and then circle. Next, we need to extract out the property, length into a new variable L, and radius into a new variable R. With those, we can implement the bodies for calculating the area. And as you can see, the resulting code is very compact and easy to read. Here we're working on a function called the scribe, which is an extension on date time. And this is meant to describe dates relative to the current date. So if we call it with 510, which is Google I/O date today, it should print out today. If we pass in 5.9, it should print out yesterday. If we pass 5.11, it should print tomorrow. And for days further apart, we'll use from now and ago. Here's the beginning of writing this function. The variable difference is a duration, and we're going to use a switch statement to pattern match on difference. We have the first matcher here. This is matching on the type duration, and we're reading out the property in days into a new variable called d, so we can print out d days from now. And as you can see, this is working quite well for these lower conditions, but we can improve the ones that are closer to today. So let's go ahead and match on the specific values 0 days, and for that we'll print out today. And we can copy this a few times, and from -1 days, we'll print yesterday. And for 1 day, we will print tomorrow. Let's go ahead and run that. That's looking great. Now we just need to fix the negative case. For that, let's go ahead and make this matcher more specific. And we will also match on the is negative property and only match when that is false. Oh, now we're getting an error. It's telling us that our switch statement is not matching on all possible cases, and specifically that we are missing the case when is negative is true. That's correct. So let's go ahead and add a case for that. And for this one, we can print out a go, and D, of course, is negative, so we can take the absolute value. Go ahead and run it. There you have it. Looking great. I really like this code. It's much more declarative and easy to read. A second Dart 3 language feature is class modifiers. Unlike patterns, which we expect every Dart developer to use, this is more of a power user feature, addressing the needs of Dart developers crafting large API surfaces or building enterprise-class apps. With class modifiers, the definition of a class that provides an API can control what consumers of the API can do. The defaults remain unchanged though. We want Dart to remain simple and approachable. So, like before, regular classes can be constructed, extended, and implemented. But what's new with class modifiers is the ability to add restrictions to this. Here are some sample uses. With an interface class, you can define a contract for others to implement. With a base class, you can disallow overriding the constructor. And with a final class, you can close the type hierarchy so that no such subclasses are possible. For details, see our new documentation on our website and the new class modifiers code lab. That's it for Dart. We expect that sound null safety, class modifiers, and patterns will make you even more productive. Let's talk developer tools next. First up is DevTools, our comprehensive suite of profiling and debugging tools. The memory page has several key new features. You can now use the Diff Snapshots tab to compare memory usage before and after an interaction. And we've enabled support for evaluations in the DevTools console while an app is running. This used to only be possible while an app was paused. You can also store object instances from a memory heap snapshot into console variables to explore the memory heap. For consistency and accessibility, we've updated all of the DevTools UI to use Material 3. Finally, the trace viewer has been completely rewritten. Rather than using a custom implementation, it's now powered by the open source tool Perfetto. This is an established, tried and tested tool which has many of the features our trace viewer was missing. These include a direct measurement tool for selecting a trace duration and advanced search with SQL queries. This makes DevTools much more capable and further solves a major point of feedback we've heard via the Flutter survey. The tool now handles even very large apps without getting sluggish. Here we have DevTools running with full frame information recorded for about 10 seconds. Let's hop over to Timeline Events, which is now powered by Perfetto. We'll start by pinning a few interesting threads of activity, the raster and IO threads. We can navigate the trace using the WASD keys, and as you can see, we have a ton of data here. This would have caused a lot of lag in our previous version, but as you can see now, it's really smooth. Before we could only select a single event, but we can now easily select a group of frames, and for those, see the slice details. To query the data using SQL, we select the search field, enter a colon, and then our SQL. Also in the tool space, we've upgraded pub.dev, the package repository that powers our wonderful Dart community. We do user research on a regular basis. Here we learned that many Dart developers prefer a visual approach when looking for Flutter widgets, and other visual packages on pub.dev. To better support those workflows, search results can now include screenshots declared by a package. We also learned there's a strong desire to enable discovery of related packages. For that, we're adding a new feature that allows package owners to add up to 5 topic tags on a package. These then enable package consumers to easily explore related packages simply by clicking the topic hashtag. While productivity is important, one thing that is even more important is security. Threats are increasing, and we have seen some examples of how even open source projects have come under attack. SALSA is a vendor-neutral initiative supported by Google to provide a set of standards and technical controls to help ensure artifact integrity. For example, enabling you to trust that the Dart and Flutter SDK and runtimes were not tampered with. Over the past year, we've worked on demonstrating that our entire build infrastructure supports SALSA. We recently completed level 1, which entails a fully automated SDK build process with generation of provenance. It is our goal to reach tamper resistance with level 2 and additional controls with level 3. Further, we'll work on guidance and tools for enabling Dart and Flutter developers to support SALSA in your projects.
Okay, now that we've spent some time covering the experience you can have as a developer, let's talk about Flutter's graphics and the experiences you can build for users. We've got updates for performance, platform details, and how to build stuff that just looks cool. Let's start with that. Today, we're announcing support for fragment shaders on the web in the stable channel of the Flutter SDK. This is a shot of the completed UI from our new code lab, building next-generation UIs in Flutter. As you can see, it's running in a browser and includes several visual effects that are created with fragment shaders. If you haven't used them before, fragment shaders, or pixel shaders, are functions that run directly on a GPU, once for each pixel within the geometry you're painting. They can alter or replace a pixel's color values, creating visually impressive effects while maintaining great performance by taking advantage of the massive parallelism offered by modern GPUs. Flutter has included support for shaders on mobile and desktop for a while. And with the 3.10 release, that support extends to the web. Here's that UI again. I can't look at it without focusing on that giant spinning orb in the center. So let's take a look at the building blocks used to create it. Orb Shader Widget is a stateful widget responsible for configuring and drawing that shape. It builds a custom paint widget, and that's straight out of the SDK, which uses Orb Shader Painter to paint with the fragment shader, which is compiled into the app as an asset. That might sound like a lot, but it's all still Flutter. Widgets are composed of other widgets. It's the same old school custom paint class that you've used before. The big deal is that the custom painter can take advantage of the shader asset when it does the actual painting. Let me show you the code. Orb Shader Widget is stateful. And here we are inside the build method for its state object. It's using a consumer from the provider package to grab an instance of the shaders class. This is just a convenience class the app uses to load the shaders from their assets once and make them available anywhere in the app. If we go into shaders, you can find this line, which is calling into the SDK to create an instance of a shader from the precompiled asset. Back in Orb Shader Widget, down at the bottom of its build method, it's creating an instance of custom paint. This is a widget from Flutter's framework, and it delegates all of its painting operations to a custom painter object created by the app called Orb Shader Painter, giving it complete control over the pixels. In these parameters, you can see Orb Shader Widget giving the painter all the data it needs to create that orb shape. Inside the config object, there are values for color and ambient light, things y'all working in gaming or 3D design are very familiar with. Here's Orb Shader Painter itself. This is the class that the custom paint widget is going to ask to paint all its pixels. And inside, you'll find a bunch of these set float statements. If you recall, the orb is constantly moving and changing. It responds to mouse movements and window resizes, and if I hover over these buttons, it also changes the color. All of that requires data from Flutter's framework about what's going on in the app. These set floats are the way that data gets sent into the shader. So all those values about lighting and mouse position that the shader needs to correctly paint this responsive orb, they go into set float and pop out in the shader as uniform values. This is the actual shader code written in GLSL, OpenGL shading language. And these are the uniform values. They're read-only and used to configure the behavior of the shader at runtime. For this app, they allow Orb Shader Painter to influence what size and color of orb is drawn by essentially feeding in constants based on the current state of the mouse and window. Way down at the bottom of the shader, by the way, is its main method, which does a lot of math to determine and return the correct color for 1 pixel in 1 frame of this orb. Going back to that diagram, you can see how this particular example splits up the areas of concern. Orb Shader Widget gathers a reference to the compiled shader and config data like the mouse position. Custom Paint handles layout and then delegates its painting to Orb Shader Painter. And Orb Shader Painter sets the uniform values for the shader and then uses it to paint pixels. By the way, this example is pretty complex and specific to this one app, but shaders can also be used for subtler effects and to make small elements of a larger design language better. For example, if you were to head over to GitHub right now and take a spin through Flutter's material package, a few clicks into the drawing code for the material ripple, that splash of color you see when you tap on a material button, you'd find this shader doing the work. It's loaded and configured using the same APIs that we just toured. If you'd like a closer look at the code for the orb example, check the description below for a link to our instructor-led workshop, Building Next-Generation UIs with Flutter, which breaks down all the steps and walks you through implementation. So, that's fragment shaders on the web, a big feature now available in Flutter's stable channel. Sometimes, though, getting graphics right is about knowing the platform and getting smaller details baked into Flutter's engine correctly. Things like formats and display types, that kind of stuff. One of those that's launching in Flutter 3.10 is support for wide gamut images on iOS. These images can take advantage of the Display P3 color space, which is 25% larger than sRGB. Using this color model can help provide users with vibrant images that really bring an experience to life. And with the latest release of Flutter, you just need to flip a flag to put it to work. Check the iOS subproject in your Flutter project folder and set FLT Enable Wide Gamut to true. Okay, so that's a bit about polish and expressiveness, which are one part of a fantastic graphics experience. Another is performance. Whether your app is able to draw itself quickly enough to keep up with modern device screens, which can give you as little as 8 milliseconds to render a frame. Over the past few years, we sometimes heard feedback from developers like, hey, Flutter's performing great for my app, except for this one bit. There would occasionally be weird edge cases, like a complex animation that had jank when it first started. The team dug into that feedback, found the root cause, and realized that correcting it would require them to literally rip out a chunk of the Flutter engine and replace it with something completely new. So they did. Let me show you how. This is a diagram of Flutter's architecture. At the top is the Flutter framework, the part most of us spend our time with. It has widgets and animations and gestures, all those APIs that we code against. Next, you have the Flutter engine, which provides foundational stuff like the Dart runtime and platform channels. All the way down, you find the embedder. These are super low level and platform specific, so there's one for iOS, one for the web, and so on. The chunk that I mentioned earlier is the bit of the engine marked rendering. This is the part that talks to the GPU and says things like, please take this image and paint it on the screen, or draw a rectangle from here to here, but clip the corners with this circle shape and then anti-alias the edges. Until now, Flutter has used a general-purpose graphics library called Skia for this part of the engine. Skia is rock solid and used all over the place, but it also wasn't designed for Flutter's specific needs. Fortunately, this layered architecture makes it possible to remove one part of the system and replace it without disrupting those APIs at the top. That means the Flutter stack itself can continually be updated and improved without requiring developers to do big refactors or put in a lot of work themselves. And that's what the team has done with Impeller, a new renderer built specifically for Flutter to maximize performance and quality. Today, we're announcing that Impeller is production ready for iOS and available in the stable channel. In designing Impeller, we've made a few architecture decisions specifically to help with common Flutter use cases. One of those decisions reduces the need for custom shaders that must be compiled at runtime and loaded into the GPU, and it does so through the clever use of triangles. Take a look at this example. GPUs are all about processing triangles, which means that if you want to render something that isn't a three-sided polygon, you need to do a little work to express that shape in the form of one or more triangles. For example, consider how to render a circle like this one. One way is to use two triangles to form a rectangle just a bit larger than the circle, and then use a fragment shader, one of those GPU programs we were just talking about, to turn the individual pixels within those triangles on or off, based on whether they're inside the bounds of the circle. The shader essentially clips off the parts of the triangles that aren't also parts of the circle and anti-aliases the edges at the same time. This approach produces great results, but it also means that for any given size, shape, what have you, that shader program is going to be different. And because the individual shapes that make up a UI are going to look different based on whatever a user happens to be doing while running your app, they can't be completely predicted at compile time and built in advance like the ones we were talking about earlier for the web. Shader compilation is one of the reasons you'd sometimes see jank in the first few frames of a complex animation and then smooth performance afterward. Creating and compiling the shaders took work for the system at the beginning of the animation. Impeller uses a different approach. Rather than using a shader to define where the edges are, it uses a tessellation algorithm to divide the circle itself into a bunch of triangles. The result is the same shape, built using a different technique that avoids runtime jank by leaning into the strength of modern GPUs. Heading back to that diagram of Flutter's architecture for a moment. One of the benefits of having all these layers is that you can replace one part of the system without disturbing everything else. So the APIs for widgets, state objects, animations, those things haven't changed. You don't need to update your app's code to take advantage of Impeller. All you need to do is rebuild your app with the right version of the SDK, and those benefits will be there. Have a go at rebuilding your apps and come back and see us with your feedback on GitHub. If you'd like to learn more about Impeller and sneak a peek at some new APIs this new rendering stack could make possible, check the video description for a link to this talk from Leah Jarrett and Brandon DeRozier right here at I/O.
Let's move to our third theme, which is all about ensuring you get deep integrations with the platform, whether it's the web, mobile, or desktop. We'll start with the web. First up, we worked on addressing the number one request we heard in the Flutter survey. Flutter web apps should load faster. The largest component inside a Flutter web app is the CanvasKit rendering engine. We reduced the size of that by roughly a third. Next up is fonts, often used to deliver symbols. We now leverage the static analysis information from the Dart compiler to shake away unused icons during compilation. This can lead to large reductions of up to 99%, for example in apps that use just a handful of symbols from a large font. In combination, these changes reduce the load time of the standard counter app by over 40%. Flutter 3.10 also adds full support for element embedding. This enables adding Flutter contents to any existing web app within a typical HTML element. And the Flutter web component integrates cleanly with the web DOM, enabling standard web features such as CSS selectors and transformations to style the Flutter component. For more details on Flutter web improvements and a cool demo of element embedding in action, check out our Google I/O video on Flutter web. A core element to enabling seamless platform integration is to ensure that you can easily call into the existing code on that platform. On the web, this is typically JavaScript code. Dart has supported JS interop for many years. Our initial model for this relied on dynamic dispatch, and thus wasn't strongly typed and could lead to runtime errors. Since then, we've tried a number of approaches to improve on this. Today, we'd like to share our recent efforts. Our goal is to create a next-generation JS interop mechanism that provides full static type safety. As you can see in the updated code, in this approach, the types are strong and clear. Online status is a Boolean, and device memory is a double. As an added benefit, this also enables code completions. Let's see how this works in practice. Here's the Flutter app that prints out the current online status, system memory, and today's date. Currently, the values are hard-coded, but let's fix that. First, we'll get the navigator from the window. Then we'll get the online status from the navigator and the memory from the navigator. As you can see, this code is really easy to write using code completions. Next, we'll get the current date. Let's go ahead and run it. And that's working great. Let's move on to integration with the mobile and desktop platforms. Google native ads are a great ads format as they allow for deep integration with the UI of an app. We've supported native ads for a while, but so far, to display a native ad on mobile, you had to write both Dart code and platform-specific code for each of Android and iOS. We've now improved the official ads plugin so that the complete integration and customization of the native app is done using Dart code, with no platform-specific code needed. To get started, check out the example in the Google Mobile Ads package on pub.dev. Mobile apps typically rely on a lot of APIs provided by the platform, whether it's notifications, payments, or getting the phone's location. Traditionally in Flutter, these are accessed by building plugins, which require writing both Dart code for the API and a bunch of platform-specific code to provide the implementation. We're currently working on a new tool called JNIGen. This can automatically generate Dart bindings for Android APIs available in Java or Kotlin code. After generating the bindings, you can go ahead and call the API like any other Dart code. Check out our Google I/O talk, Rethinking Dart Interop with Android, for more details.
Let's take a moment and talk about another theme, Flutter on new and emerging architectures. In the past, when we've covered this topic, it's often been in the context of growing Dart's instruction set targets or Flutter's platform support, such as when we added stable support for macOS at last year's I/O. Today, though, we have an opportunity to talk about an emerging architecture for one of the platforms Flutter already supports, WASM for the web. WebAssembly, or WASM for short, has been around for a while. It's a binary instruction format designed as a portable compilation target for higher-level programming languages. It's an open standard and supported by major browsers like Chrome, Firefox, and so on. WASM was created to help developers build rich, high-performance experiences for the web. Now you might hear that and think, that's exactly what the folks from Flutter say Flutter is designed to do. And if so, you're not wrong. The goals of both projects are well aligned, and so this is a really cool opportunity to modernize how Dart and Flutter applications are running on the web. That has the potential to bring faster load times, more responsiveness, and a better interop experience for plugin authors who want to build integrations with WebAssembly libraries. Up until now, though, WASM hasn't supported garbage collection, which is a blocker for Dart, a garbage collected language. But thanks to the recently adopted WASM GC standard, which defines an approach for garbage collection and apps built into WebAssembly, it's possible for Dart and Flutter to take advantage of this new architecture. In the next few minutes, I'm going to show you how you can try building a Flutter app into WebAssembly using tools you probably have on your development machine right now. Okay, so I'm in my source directory, and I've got Flutter here set up on the master channel. And that's important because this is an experimental compilation architecture I'm showing you here. And so it's only available on the master channel. All right, now I'm going to do Flutter create. I'm just going to create a brand new project here. Let's call it WASMtastic. I'm going to need somewhere to host this web app, right? I can run it locally, of course, but what's the fun in that? Let me go ahead and set up a host. And I happen to use Firebase web hosting a lot, so let me initialize that here. All right, let me go down and pick a hosting, and I'll create a new project, and I'll just call it WASMtastic host. This will be a new Firebase project that I'm creating here. And there's nothing unusual about this at all. This is just a regular Firebase hosting project that I'm setting up. Although right here, I do have to stop and pay attention. So by default, Firebase uses the public directory as its public directory. And what I want to use is build/web_wasm. This is the directory in which Flutter is going to place the compiled WASM, the HTML, and so on, that is the built version of my web app. And so I want Firebase hosting to use that directory. And so I won't configure this as a single page app, but I want any URL redirecting there. And automatic builds and deploys with GitHub are awesome, but I don't really need them for this demo. So I'm going to leave those off for now. And there we go. So Firebase initialization is done. Now it's time to build this app. I can do that with Flutter build web --wasm. And it's that --wasm that's the new part. And you can see right there the experimental warning. And there goes my compile. And I'm good. Okay, so I've initialized Firebase for hosting. I have built the web app into that build/web_wasm directory. And let's take a quick look at that. You can see all the things that you'd usually expect, index.html, the fav icon and stuff like that. And I've got main.dart.wasm. That's the new part that I'm getting from building with Wasm. Okay, time to do a Firebase deploy and get this baby up on the web. Cool, so the Firebase command line tool has done its magic. All my assets are up on the host, and I have my hosting URL. So wasmtastic-host.web.app. Let's go ahead and click on that, and I get a blank white browser screen. So what's going on here? Let me pull up the inspector real quick. And some of y'all will immediately notice 2 red errors there, right? I've got 2 errors here relating to WASM and some interfaces that aren't found. This is because the WASM GC standard is still behind an experimental flag in Chrome as well as the Flutter tool. So let me open up my Chrome flags here, and I'm going to turn on 2 of them. So I've got the experimental WebAssembly promise integration, and I've got WebAssembly garbage collection. These are both currently disabled, which is the default right now. And I'm going to go ahead and enable both of these. And then Chrome is going to ask me to relaunch, which is fine. Again, this is the regular stable version of Chrome. This is the one you would download just as a typical Chrome user. All right, both those flags are there. And now my app is ready to run. There it is. And if I head into the inspector again, you can see I got no errors here. And if I go into sources, you can see that WASM file is right there being served up by the server and executed by the browser. Again, this is the stable version of Chrome. The only difference here is I set those 2 experimental Chrome flags. You might be surprised how far you can get, even though this is still an experimental compilation target for Flutter. Here, for example, is the material demo from the Flutter/samples repo. And Kevin Moore has removed the URL launcher plugin. That plugin hasn't been updated to work with WASM yet. So he pulled that out of this, and you can see everything else is working just fine. I've got buttons in here. I've got navigation doors and pop-ups. All of those things are working as expected, despite the fact that this has been compiled in a fundamentally different way than you normally would for the web, taking advantage of WebAssembly. And again, I'm not using anything special here other than the master channel release of the Flutter SDK and a stable version of Chrome with 2 experimental flags turned on. So that's a quick look into how Flutter is working to take advantage of the capabilities provided by WebAssembly. If you'd like more info, head to flutter.dev/wasm for docs and some useful links. All right, so that's the latest on Dart 3 and Flutter 3.10, plus a look at a few things that'll continue to land over the next few versions. Hopefully you've gotten a great view of not only the experience you can have as a developer with Dart and Flutter, but how their graphics performance, integration with platforms, and support for new and emerging architectures can help you build fantastic experiences for the users of your apps. If you've made it this far into our talk, you're probably interested in some additional content, and we got a bunch, including deep dives on the Flutter and Dart SDKs, our integrations with Firebase, and even a full video walkthrough of the Fragment Shader Code Lab I mentioned earlier. So check for those in the description below. Come visit us at dart.dev and flutter.dev, and we'll see you next time.